So today I'm going to give you guys lessons on how to throw a boomerang. I'm just kidding, my friends. We are actually going to go over the measurement report of the Yamaha CX-A5200 and MX-A5200 11-channel processor and power amp separates after the intro. Hey folks, I'm Gene Delasalo with Audioholics, and I know you guys have been waiting a long time. You've been wanting to see how these products bench test. The Yamaha Avantage, this is their third generation of separates that we've covered on their Avantage line. Now last year I did a pretty thorough review of the CX-A5100, and I covered the MX-A5000 many years ago. That was the first generation 11-channel amplifier that they came out with. So today I'm going to show you what the differences are. But before we get into the formal review of all the operations and all the features, I want to sit down with you at my desk. I want to go over the measurement results. I want to interpret those measurement results. I want to show you what it means, all the power, the distortion specs. What about that new feature that has a bridged mode on the amplifier for the 5200? I'm going to show you what that's all about, how much extra power you get. So let's go over into my office. Let's go check it out right now. All right, my friends, we are here at my test bench. We're going to be going over the Yamaha CX-A5200 11-channel processor and the MX-A5200 11-channel power amplifier, which is rated at 150 watts times 11. So before we proceed to showing you the measurement report, I think it's important to note that we are fortunate at Audioholics to have the industry's most advanced HDMI 8-channel analyzer. It's the Precision APx585. So anybody really serious about doing measurements and components should have an Audio Precision, whether it's this unit or System 2722 or System 2. These are all top of the line audio analyzers, and I'm glad that I have one of these at my disposal so I could do all these measurements for you guys. So let's go over the report. Now, I'm going to be dropping the formal written review probably shortly after Thanksgiving in the next couple of weeks, and then I'll do another YouTube video that goes over all the features and the setup of this CX-A5200 and go over a little bit of the listening tests on that one and the 11-channel power amp. But I wanted to start here with the measurement report, and what I like to start out with is I always check from input to output through the analog circuits what kind of voltage drive a preamp can give, make sure it doesn't clip at a low voltage, because we want to be able to drive a wide assortment of amplifiers, and I like to see at least a good solid 2 volts RMS output out of any preamplifier as a very minimum. Typically I'd like to see 4 volts, because if 2 volts is right at the clipping point, then you start getting some pretty nasty harmonics when you do an FFT on it. So I like to have a lot of headroom. I really like to see a good clean 4 volt RMS when you're dealing with preamp processors. So this unit is able to accommodate a clean 4 volt RMS input without clipping or distorting the input. And it's similar to the last two models that Yamaha produced, the CX-A5000 and the 5100. So you get about 8 volts RMS out, unclipped, measured 7.8, pretty similar. I don't think much of the gain structure changed out of any of their Avantage series processors. It's pretty similar to the first generation. But you know, just to do my good housekeeping, I ran an FFT, and I started with the HDMI input at minus 10 dBFS digital signal and 1 volt RMS output. You can see the spectrum here is really clean. The second harmonic is like 105 dB below the fundamental at 1 kilohertz, which is excellent. I think that's a distortion of 0.015. It's really low. A little bit power supply hum here, which is typical when you're dealing with linear power supplies. You could get some of that. Not that bad. I mean, we're down in the noise floor here. But what's interesting is when I started driving the levels up beyond 2 volts, I started seeing some pretty nasty FFT results. So I wanted to take a closer look and compare it to the other channels to see what was going on. And what I did was I did a 1 kilohertz sweep of voltage versus distortion. These are the other 5 channels, the surround channels. Remember, I can only test 8 channels at a time. I'm not going to be able to test all 11. But you can see that all of the surround channels on the XLR outputs track very low distortion all the way up to 8 volts out. That's excellent. It's like 0.001, 0.0015 or 0.015, really low. But then the main left and right outputs, they're much higher in distortion than I anticipated, and I was really surprised at this. If you notice, it rises at above 2 volts. This is the 2 volt mark here, and it just starts going much higher than the other channels. Now, to put things into perspective, I don't want to scare people. I mean, this is something I measure on an analyzer. It doesn't mean it's audible. When you think about it, even if you're driving this at 4 volts RMS to drive your amplifier at full power, which is well beyond what any amplifier would need, at 4 volts you're still below 0.02% THD, which is really excuse me, which is really good. So I just wanted to see why this is the case, and I was curious, and I tested the unbalanced outputs, and on all the channels it was super low. It was like looking at the levels for the surround channels on the XLRs. And that's usually not the case. I mean, usually XLR should be as good or better than unbalanced. And in fact, if it's a true differential circuit from input to output, you should be able to see up to 6 dB lower noise and distortion from the truly differential outputs as opposed to the single-ended outputs. But most XLR outputs on consumer products, including this Yamaha one, including similar priced Denon, Marantz, Integra, Pioneer, they all use a phase splitter at the very last stage, so it's not a true differential circuit from input to output. Very few products on the market in consumer audio are. Like, for example, the old Denon AVPA1 HDCI, which I love that processor, was a fully differential from input to output. But that was a $7,500 processor, and we're talking about, you know, a $2,000 or $3,000 product here. So it's obviously a much different price class, so it's to be expected. But anyways, it's interesting to see that the unbalanced has lower distortion than the balanced, and that's not typical behavior. And I wanted to kind of check this out to show you the differences between the 5100 model, which I had in my rack for about a year, versus the 5200, which is the one we're testing now. So if I ran both of them at 2.7 volts out, which is right at about the maximum voltage required, or I'm sorry, the minimum voltage required for the MX-A5200 to reach full output, to reach its full rated power. If you look at the distortion coming out of the 5100 versus the 5200, the 5100 was much lower, especially on the XLRs. So in this case, the XLR is red, and then the unbalanced is the yellow for the 5100. And you can see at very low frequencies, the XLR has the advantage. That just cancels out probably the power supply noise that we were seeing because of the plus and minus phase cancellations. So, but above 500 hertz, they pretty much track. And it's really low, like minus 90 dB distortion. Well, when you look at the 5200, these are out of the front outputs. Holy cow, the balanced outputs are like at minus 70, and the unbalanced are a little bit above minus 90. So when you do a direct comparison, there's about a 23 dB difference in distortion between the 5100 and the 5200. That's pretty surprising. It's surprising, but it's probably not audible because I've done a lot of tests listening wise on the 5200, and I didn't feel like I was giving anything up to the 5100. But again, this is just an exercise in measurements and being objectively analyzing products. So I took this information to Yamaha, and of course their engineers in Japan have a similar setup that I do. They have the Audio Precision 585 as well. It's a $40,000 analyzer, just so you guys understand the investment involved in doing these kind of measurements. And they basically confirmed what I found, that my measurements were accurate, and unfortunately they traced it down to a problem, something to do with the volume control and how it interacts with the balanced circuits on this unit. And it's only doing it on the XLRs for the front channels. It's not doing it on the unbalanced channels. It's not even doing it on their 3080 model, which is the receiver that has XLR outputs. So that's immune from this. And unfortunately, they can't fix this because it's a hardware change that has to be done. So for this model, it's going to stay. The distortion profile, like I measured, is the characteristic of this product. There's nothing that's going to change about it. but for future models going forward, they're going to address this. And again, I don't want to scare people into not buying this product because of this measurement, because I couldn't really hear the distortion. And I do critical listening, and I've got, you know, $50,000 reference RBH speakers in an acoustically controlled room. I can measure it on my audio precision, but my audio precision is thousands of times more sensitive than my hearing, thousands of times more accurate, thousands of times more consistent. So I really think that's important to stress to you guys. So moving on, you know, we checked the frequency response on the XLR outputs, and it was, of course, excellent. The nice thing about this product is, because it's got such good D to A converters, it has the top of the line ESS Sabre DACs, and they have a very high sampling rate, even when you engage the DSP. Many products on the market that have room correction, when they engage their room correction systems, they sample at 48 kilohertz, so you have a 3 dB point at 24 kilohertz, and it's like a brick wall. Now obviously 24K is above human hearing, but there's an argument to say that you don't want to have a filter close to the limits of human hearing. You want to have it, you know, about an octave above that. Well, the Yamaha processing here does just that. So you got, you know, a 48 kilohertz sampling rate. I'm sorry, an 88 kilohertz sampling rate. So you have a 3 dB point at 48K, about 44, 48K when you engage the DSP. And of course, when you don't engage the DSP, the minus 3 dB point is like 70K. So it's like at the frequencies bats can hear. So the frequency response is really good, and the channel-to-channel variance was excellent. It was like 0.06 dB, or something really small between channel to channel, which is pretty awesome, because back in the day when we had all analog volume controls for all the different channels, it was hard to get this kind of precision that you can now do in the digital domain. So we've come a long way, my friends. Bass management was excellent as expected. Just checking at 80 Hertz, I wanted to make sure that all the crossovers sum correctly. And you can see here at 80 Hertz, the low pass is a 24 dB per octave, and the high pass is 12 dB per octave, just like kind of the THX spec. Textbook crossover here, perfect integration. The one thing I do want you guys to note, two things actually. Yamaha unfortunately got rid of their feature to have an independent LFE crossover point. I like some of the Denon and Marantz products that actually, and even the Integra products, let you change the LFE setting, which is independent from your bass management for your speaker management. And the LFE track in Blu-rays is typically rolls off, or the bandwidth of it is about 120 Hertz. And that's what you typically want to keep it at. In most installations, you want to keep it at the 120 Hertz. Yamaha doesn't even have the ability to adjust that. But after testing it, I've determined that that's basically the default. It's programmed into the unit. So that's not something to worry about too much. But one thing to note is if you're running large speakers on this and you engage the enhanced bass, so you can have your subwoofer engaged during 2-channel, make sure you set your crossover point on your main speakers before you set them large. Otherwise, in 2-channel mode, whatever that crossover setting was for your main speakers, that's going to be the crossover point that it selects for your subwoofer output. So keep that in mind. Like for example, set all your speakers to 80 Hertz, and then if you have large speakers, set your main speakers to large, and then your subwoofer output will be crossed over at 80 Hertz when they're playing 2-channel music. So something definitely worthy to note. So looking at the signal to noise ratio, it's excellent. It's like over 100 dB with a minus 10 dB FS signal with 1 volt output using the HDMI inputs. When I ran an analog input at 200 millivolts in, 1 volt out, it was still excellent. It was about 95 dB, and these are all A-weighted measurements, by the way. So SNR of anything greater than 90 at low voltage like this is just excellent. It means you're not going to hear hiss out of your speakers, even if you have, you know, a clip speaker that's a high sensitivity speaker. It's a very quiet sounding preamp. Now that's when you're using the digital to analog converters, or you were using the pure direct mode. Unfortunately, when you use the analog to digital converters, I noticed that the noise floor went up significantly. The similar type of measurement when I was engaging the DSP from an analog source was like 81 dB A-weighted, as opposed to 95 dB when I was using the digital source and then converted to analog. And I checked with Yamaha just to make sure this was right, and they basically said that they put all the priority into the engineering of the DAC but not the ADC. They use the really high performance DAC, but then they use kind of an average performing analog to digital converter. So if you're using, if you're going to play vinyl on the Yamaha 5100, or you're going to play some old tapes, reel to reel, or you're going to play an analog source, you want to do that in pure direct mode. You don't want to engage YPOW. You don't want to engage the DSP if you care about, you know, pristine fidelity and keeping your noise floor low. That's what my recommendation would be for that. So channel to channel crosstalk I measured as well. And this basically tells you your stereo separation. Now, back in the day when magazines used to measure component performance, which they don't do anymore, they typically would measure one channel as a disturber and the other channel as the channel under test to see what the crosstalk was. I take it up a notch. I actually run all of the channels, so in this case 7 channels running, while I check the 8th channel with nothing on it to see how much crosstalk goes into that channel. That's a much harder test to pass. Usually it makes, you know, a 5 to 10 dB difference in these measurements, but I like to be very conservative in what we report. So here you're looking at this with all the different channels driving with one channel under test, and then the system just kind of varied between channel to channel and it plotted this result. This is pretty damn good. It's like minus 70 dB at 20 kilohertz. I consider anything better than minus 60 at 20 kilohertz to be really good. So you have good channel separation for a product that has all of this sophistication in it. You're talking about a product that has 11 channels of preamplification, all this DSP, the clocks, you know, the DACs. There's so much stuff going on in there. So in fact, that Yamaha, you know, did a good job with board layout here, and they got the noise and the signal to noise ratio good in the product, and they also got the channel to channel isolation good. So let's move on to the 5200 amplifier, the 11 channel amplifier. Now this was rated at 150 watts times 11, and based on the older model that we reviewed, the MX-A5200, it can't do 11 channels at 150 watts. It's just, it would require a bigger power supply, and you know, it would just, it's not realistic to do 11 channels with this kind of product. But that being said, in most cases you don't really need to deliver that much power simultaneously, because think about it, the 4 extra channels that you're running now are Atmos channels or height channels. They don't use a lot of power. They're more effects channels. So in reality, you're not going to really ever drive an amplifier with all 11 channels driven at full power. You would blow your ears out, and it just would not be pretty. So I do check continuous power with 2 channels driven at 8 ohms and 4 ohms. I check a 1 kilohertz power sweep. Those are the kind of tests you used to see the magazines do. They would always test only at 1 kilohertz. They would never do full bandwidth testing like we do. And then we do dynamic testing using a CEA 2006 burst test, and that simulates kind of music program material that used to be used in the car audio industry. And I think it's a good test to use here. So I measured the frequency response of this amplifier, and it's excellent. 20 to 20 kilohertz, the channel to channel variance is only 0.06 plus or minus 0.062 dB, which is great. The gain structure is pretty similar to what you would find in any THX rated amplifier, even though this is not a THX amp. It's just good design practices. So the unbalanced gain is 29 dB and the balanced gain is 23 dB. And the reason why that happens is when you have a balanced processor, the balanced side has 6 dB more gain than the unbalanced side. So it kind of all evens out when you use balanced to balanced or single-ended to single-ended. But the one interesting thing is this amplifier, unlike the 5000, it has the front channels are bridgeable. And what a bridge tied load does is it takes 2 channels and it ties them together at the output stage. So the load, or the speaker, instead of seeing a positive from an amplifier and then ground, it now sees a positive from one amplifier and a positive from the other amplifier with the phase reversed, ties it together at the speaker, so the speaker doesn't see a ground anymore. So the advantage of having a bridged amplifier, theoretically you can get up to 4 times the power when you bridge an amplifier with 2 equal rated channels. You never in practice really get that much power. You typically get twice the power, just because there's so much current limiting that has to go on, because you just can't, you know, most transistors can't deal with that much power unless you have some really robust design and a really big power supply. So we typically see twice the power with a bridge tied load. And it was kind of weird to me at first when Yamaha rated this amplifier at 150 watts times 11 in single-ended version versus 200 watts times 2 in bridged version. Like, why didn't they rate it a lot higher than that? I figured they must be doing some major current limiting, so I couldn't wait to get this on the bench to see what was going on. So we look over here. This is an interesting rating here. When I measured this amplifier, now this is a continuous power rating from 10 hertz all the way out to like 50 kilohertz. So I tested this full bandwidth. I got 250 watts a channel, both channels driven at 8 ohms, bridged at less than 0.1% THD plus N. Now that far exceeds what Yamaha spec'd this. Yamaha said this was only going to deliver 200 watts a channel at 8 ohms bridged. So I was pleasantly surprised to see that they actually out-delivered, which is great because there's really benefit here. If you're not using all 11 channels to power all your speakers, let's say you're only running 9 speakers in your theater room, you're definitely going to want to bridge those front channels to get this extra power, so you have more margin and more headroom to your speakers. So when we tested this now at 4 ohms, this is a hard test, by the way. Keep in mind, when you bridge an amplifier, each side of the amplifier sees half the load impedance. So that 4 ohm load, each side of that amplifier now sees a 2 ohm load. So that's sucking a lot of current out of the power supply. This thing was able to do 388 watts a channel, both channels driven at 4 ohms bridged at less than 0.1% THD plus N. That's awesome. I mean, that's a lot of power coming from, you know, a Japanese 11-channel power amplifier. It's a multi-channel power amplifier. So I was really happy to see that. And you notice the frequency response was consistent. There wasn't any weirdness going on at high frequencies just because of the load impedance. That's the one advantage you get with linear amplifiers over some of the Class Ds, is the output response, the amplitude response doesn't vary with load impedance, which is great. So then I ran some power distortion sweep tests at 1 kilohertz just to see you know, how much more power we would get under these kind of ratings, which you see in the magazines, how they used to rate them. And I wanted to see how this compared to the MX-A5000, and it was about the same power. I measured maybe 10 watts less with 2 channels driven unbridged. I measured 150 watts at 0.1%. 2 channels driven 8 ohms, and 171 watts 1%, same test conditions. So the MX-A5000, when I measured it 5-6 years ago, measured a little bit higher. That just could be line condition voltage line differences between when I measured it here versus when I measured it 5 years ago, or just part differences, you know, just tolerance differences. The bottom line is the amplifier is basically the same thing, except for the fact that you can now bridge 2 of the channels. So when we do the same test, bridging those 2 front channels, we get 250 watts into 8 ohms, both channels driven. At 0.1%, 277 watts. At 1%, got a 396 watts at 2 channels driven at 0.1, and a whopping 444 watts at 1% with both channels driven at 4 ohms. Now 1% is right getting to the onset of clipping, so it's still a pretty clean signal. That's impressive power, my friends. For a $2,500 amplifier that does 11 channels, you could bridge 2 of the channels and get over 400 watts a channel for your front channels. That's pretty awesome. I'm really happy about that. But there's a caveat to the bridging, and this is one of the Achilles heels for Yamaha on this amplifier. I thought I was going to be smart. I thought, because I have my own separate amplifier powering my big speakers, I thought I could use the remaining 9 channels to power the rest of my speakers and bridge 2 of the amplifiers to my center channels so I could get more power. Now, my speakers, because they're the Status Acoustics AT and they dip down to 2 ohms, I need a good kilowatt per channel to run those speakers, to do justice to them, and to run, you know, full range bass through them. Did not want to subject them to this amplifier. So that's why I wanted to use this amplifier to power the rest of my system. So I bridged 1 channel, and I was like, I want to just check the other channel that's unbridged just to see what happens. Well, when I did that, it neutered it. I mean, the power that was coming out of that 1 channel, that was unbridged. It was supposed to be 150 watts. It was down to 65 watts at 0.1%, 72 watts at 1%. It was less than half the power. And the reason for that is what happens is when you put this amplifier in bridge mode, just like most well-designed amplifiers, they're going to do some limiting on that power supply because they don't want to overdrive it. They have a different tap on the power transformer, so they go to a lower voltage tap. So on this amplifier, just bridging one channel puts both of those channels, the left side and the right side, into the lower voltage tap. So if you don't select bridge on another channel and you run it as a single channel like this, you're severely limiting the power. And I don't recommend you ever do that. If you're going to bridge this amplifier, use both channels in bridged. And I hope if Yamaha watches this video that they listen to me and they consider in future models to not make each channel, to make both channels dependent on that. So in other words, if you're only going to bridge one channel, the other channel should stay on the high voltage rail. But to make things even better, what I would like to see Yamaha do is I'd like to see them have the option to bridge any channel groupings that people want to bridge. And, you know, to sweeten the deal, give us a little bit of a bigger power supply in this thing, so that way we can really take advantage of the bridge feature. Because the last time I tested a bridgeable multi-channel amplifier was on the Denon POA A1 HDCI. That was a 10-channel, 150 watts times 10, 300 watts times 5 bridge. That was awesome because I got double the power. I was able to bridge a 10-channel amp into 5 channels. That was very useful. Now, to Yamaha's defense, this product is only $2,500. The Denon was $7,500. So that's a huge step up in price. But let's say Yamaha decides next iteration of this product to raise the price to $3,000. Give us a 25% bigger power supply in the thing. Beef up the heat sinks a little bit more if you want. And let us be able to bridge any channel groupings we want. That would be awesome. Now, another thing I'd like to say about Yamaha that I'm really impressed with this amplifier is I beat the snot out of this amplifier. I hit it hard at reference levels in my 6,000 cubic foot room. And it really didn't break a sweat. Like, it didn't get hot. Like, I could put my hand on it after playing music or movies for several hours and it was warm. It was never hot. It was never burning my hand. I never heard the fans. There's fans underneath the power supply at the bottom of the unit. Never heard them turn on when I was using the amplifier. The only time I may have gotten them to turn on was when I was doing some really rigid bench tests for continuous power ratings. Running sweeps for very long periods of time was the only time I would ever hear the fans go on, and they were very quiet fans to begin with. So that's a good thing. For dynamic testing, I ran the CEA burst test at 4 ohms and I got about 450 watts. Now that's the one thing I find interesting is usually when I run dynamic test, the dynamic power is usually like a dB.5 higher than the continuous power. That wasn't the case with this amplifier, and I think it's because of all the current limiting that they're doing in the bridge mode because they don't want to overload this amplifier. So if you run it in unbridged mode, you see that there's more headroom, but you also won't get, 450 watts. So 6 one, half a dozen of the other. I mean, I'd like to see more headroom in an amplifier than this, but I'm not going to complain too much that I'm getting a clean 450 watts out of this unit. So I have the data table here. This will be in the written review that you guys can see when I post it. And I just wanted to recap. What I have here for 2B, that means bridge mode, 2 channels driven bridge mode. The asterisk, the 1 asterisk is just data that I took from my 5000 review, the predecessor to this unit. And then a double asterisk is the current protection engaged when you drive 7 channels like I was talking about earlier before. So I didn't check 5-channel and 7-channel driven on this amplifier because it's basically the same amplifier as the 5000. So the results are pretty similar. So you can see the data here. It's some good numbers. Even with 5 channels driven, we're getting an honest, 144 watts, close to its 150 watt rating at 1%, which is below clipping. And that's pretty good. I can't really complain about that. When I got into the 7 channels driven, I started seeing current limiting. But again, that's something that happens on a bench with continuous sweeps. It doesn't happen when you're listening to dynamic music program material. Didn't have a problem with this when I was actually playing it in my theater room. So I wanted to show you, because I go a little bit closer into detail with this stuff when I do the FFTs. I wanted to see what this amplifier looked like with just 1 watt output, because you know the first watt really matters, and that's something that you've heard from maybe Nelson Pass said that from Past Labs, and I agree with him on that. So the blue is the unbridged, and then the red is bridged. Now the interesting thing here is when you are unbridged, there is some power supply hum in this thing at 120 hertz, which is twice the 60 hertz line. That's through the kind of the rectifier circuits. It's pretty high. It's not horrible. I mean, minus 90 dB is definitely not audible. I never heard hum. It's about 4 or 5 dB higher than what I measured on the MX-A5200. But when you put it in bridge mode, it cuts it to way below that. Like it cuts it a good, about a good 15 dB or so. Now, the distortion profile, it actually cleans up in an FFT. When you do bridge mode, it gets rid of some of the harmonics between the second and third, you know, these little residual harmonics. But the odd order harmonics went up about 10 dB, but the even order went down a good 5 or 10 dB. So I mean, it's, you know, it's comparable. It's not as like you would typically expect to see a bridged amplifier could just cut all the distortion products lower. This was kind of, you know, lower in some aspects, higher in others. The weird thing about this is I couldn't get consistent results. Like if I ran this test 4 or 5 times, the FFT response would change. I'd never seen an amplifier drift like this before with an FFT. I can only think that it has something to do with some current sensing that it's doing in bridge mode, and it's just changing the bias. It's checking and changing the bias or something, and that's what's giving me erroneous results. Again, this is mostly academic. I don't think it's something that would be audible. And you can see at 150 watts, with this thing really blasting, still got a pretty decent FFT. I think the harmonics were down 80 something dB from the fundamental. It's not the best I've seen. It's definitely not state of the art, but it's definitely clean, and I'm not going to complain too much. And the same thing when I ran it in bridge mode. See, a lot of the residuals kind of canceled out. So you're definitely going to get, I think you're going to get a fidelity improvement when you run this amplifier in bridge mode. If you have speakers that are power demanding, then you're going to see a benefit running the 2 channels in bridged over having unbridged. So that's an improvement, I would say, for the 5200 over the 5000. And here's a good test to show you guys. So I ran this thing at 255 watts with 2 channels driven, 8 ohms bridged. And this is distortion versus frequency at full power, above rated full power. So it's the rated power is 200 watts. I was driving it at 255 watts. And you can see even out to 20 kilohertz, we're below 0.05% THD plus N. So that's excellent. I mean, that shows you that this amplifier, you know, is clean even at high power. So that's about it. I hope you guys enjoyed this, and I wanted to show you real quick. I think I have the back panel. For anybody that's wondering about the bridge feature, here's an array of buttons on the back of this receiver, so you could select between what channel you want to control. There's a little bridge button here for channel 3 for the right side, and then channel 3 for the left side. And what you do is, for single-ended, you go between plus and minus, but for bridged, you go between these 2 connections here. So it's 2 plus amplifiers that you go, and they're labeled, so the plus side is here and the minus side is there. I mean, it's pretty self-explanatory, and I'll show this a little bit more in the formal review. So that's it, my friends. Overall, the measurements were good. There were some problems that I found that were mostly academic that I don't think will translate to real world. It's something to note, and I hope that Yamaha will take this constructive criticism and bring it back to the drawing table when they come out with the next iteration of these products and make them even better, so I could come back and just kind of glow all over the measurements of what I found. But please don't let this deter you, because I really do enjoy these products. You know, for their price points, I think they're positioned in a really well in the market. I mean, the Avantage products are built really well. They're very reliable. There's a lot of features that I think people will enjoy, and I'll talk more about that in the written review. So I hope you guys enjoyed this video, and I really implore you to share this video, like it, subscribe to our channel, thumb it up. Please give us some comments down below. YouTube has got this algorithm thing now where if you don't get a lot of comments and a lot of likes on a video, it stops sharing it after a few days. So I really appreciate you guys getting the word out for us. And please join our Patreon at patreon.com/audioholics. You get to see unique content there that sometimes we don't post here. You get to ask us one-on-one questions. You get to see content first before it comes on YouTube or audioholics.com. So I hope everybody's doing well and a happy Thanksgiving. And until next time, my friends, keep listening.